Hello, this is Team 6 and we're going to talk about hydrocarbons. Hydrocarbons are organic compounds formed mainly by carbon and hydrogen. Hydrocarbons can be in the form of alkynes, and aromatics. They are named by UPAC. UPAC is the nomenclature of organic chemistry. It's a systematical method of naming organic compounds as recommended by the International Union of Pure and Applied Chemistry.
4 methyl, 5 propyl. Here's the other equation. First we'll choose the longest chain, that it is this one. Number the positions. We start from the left to right because it's the first. It's 1, 2, 3, 4, 5, 6. Then the substance. So this will be the methyl and ethyl. From alphabetical order, these 2 ethyl, 3, 4 the methyl, hexane, because they are 6 carbons. The last equation, first will always be the longest chain, that this is this one. Number from left to right in this equation will be the same. You can number from left to right or right to left. We're going to do right to left. 1, 2, 3, 4, 5. The substituents in this equation, it will be 3 methyl, so it will be 2, 3, 4, 3 methyl heptane, because they are 5 carbons, and here will have 3 methyls, and the position are 2, 3, and 4 methyls, and the position are 2, 3, and 4.
Well, I'm going to explain the alkenes. The alkenes are unsaturated hydrocarbons that contain one or more double covalent bonds between carbons atom in a chain. And well, the rules to name the alkanes are: first we have to identify the longest chain. For example, in this case, this is the longest chain because it has 4 atoms. Then we have to number the parent chain starting from the number where the double bond is closest. In this case, is this one. Then we have to identify the substituents, and in this case we have 2 of them. The double bond, in this case, is this one. Then we need to identify the substituents. Here we have a methyl and an ethyl. After this, we need to name them in alphabetical order. So first we have the ethyl. 1, 2, 3, 4. So it is 4 ethyl. And the methyl is in the third atom, so it is 3 methyl. Then the double bond that is in the first one is 1, and as the parent chain has 6 atoms, it is an hexene. Now we have another one here. We need to identify first the parent chain. It's this one. Then we have to name the atoms. And then we have to name it. This is isopropyl, and this is a methyl. So first it goes to isopropyl. Then the methyl is in the third atom, so it is 3. And the double bond is in the first one, so it is 1. And as it has 4 atoms, it is a butene. Now we are going to learn how to draw the structural formula of alkanes. First, we need to draw the parent chain that, well, for example, in this case is an hexene, so we need to draw 6 atoms. Then we need to identify the substituents. For example, in this case it says the substituents are in the places number 2 and 3. But first we need to draw the double bond. So it says here it is number 1, so you can put it wherever you want. By which side you want, just that it needs to be in the first position. Then we need to identify second position and another one in the third, and both are dimethyl, so we need to count 1, 2. So here is 1 methyl, and then it says there is another methyl in the position 3, so here we draw the other methyl. And that's all. Now we have our own chain. Now we are going to see 2 more examples. So here it says it is a butene, so it has 4 atoms. Now the double bond is in the first position, so we draw it here, and then we need to identify and now we are done.
I will show you how to name alkynes. The alkynes have the dual homologous series of organic compounds of hydrogen and carbon, where there is at least one triple bond between the atoms in the molecules. The first step you have to do is find the longest chain, like in this example. The longest chain have to have the triple bond, like here, and you have always named the alkynes with the termination Y and A. When there is more than one triple bond, you have to use the prefix D or 3, depending on the situation. The second step, number the carbon atoms in the main chain. You have to begin in the way that the triple bond is in a lowest number. In this case, since both sides is to 3, you have to start with the one that have the prefixes closer. So this will be number 1, number 2, number 3, 4, 5, and 6. Correct. Then you have to identify the branches and then giving the name to it by putting first the branches in alphabetical order. Like here is 2-methyl, 2-ethyl, 3-hexane. How do you know how this will be called? By this chart. When the longest chains have 1, it's called meta. When we have 2, it's called eta. We have 3, it's called proper. For Buddha, Penta, Hexa, Hepta,
the branches. When it just have one, it's called methyl. When it have two, it's called ethyl. When it have three, it's called propyl. And when it have three, but is connected by the middle, it's called isopropyl. Let's see another example. We have this. So we have to name it first, put the longest chain, and then arrange them 1, 2, 3, 4, and 5. So here we have an isopropyl into number 3 and methyl into number 1. So since you have to put it in alphabetical order, you put first the isopropyl. Carries into number 3. Number 3, isopropyl. Then the methyl. Then you put where is the triple bond. 1. Then you count the parent chain, and this have 5, so it's called penta. Another example will be this. First you have to look for the longest chain with the triple bond, but in this case it's this. Number it 1, 2, 3, 4, 5, 6, and 7. And you have one prefix. Okay, so it will be 6 methyl 1 and 3 hepta D. Okay, now let's do it from the name and draw the chain. Okay, we have 5-ethyl, 5-methyl, 3-heptane. We know that hept means 7, so we have 7 carbons first. 7. And we know that in the number 3 we have the double bond. So we know that here we have a double, triple. So in the 5 we have ethyl and methyl. So we start drawing the hydroxide. 3, H2, H2, H3. And we give ethyl and methyl. And this is our 10. Another example of this will be 2-ethyl 3-hexane. So we know that hexa means 6. So we have 6 carbon 6 carbons. Then you know that in the number 2 there is an ethyl, and in the number 3 there is a triple bond. So you start from the hydroxide and here is H2 and H3. And we have our last example is 3-ethyl 4-propyl 1,6-heptadiene. Okay, we know that the number 1 have a triple bond, and with the third one there's a ethyl. So we have like this H2 ethyl. The number we have propyl, propyl. Number 6 we don't have anything. Into number 5, sorry, and into number 6 to number 6 we have a triple bond joined with a CH. That's all. Now you know how to name alkynes.
Hi, the hydrocarbon. I'm going to talk about the hydrocarbon. The carbon compound made the hydrocarbon. The hydrocarbon made aliphatic hydrocarbon and aromatic hydrocarbon. The aromatic and aliphatic hydrocarbon made benzene ring, and the aliphatic hydrocarbon made in three parts: alkaline, alkaline, and alkaline. The alkaline made cycle alkaline. The derivative of hydrocarbons is the alkene, halise, and aldehydes. Aldehydes is made ketones, and ketones made ether. The alkyls made alcohol, and alcohol made amines. Amines made carboxylic acids. Hydrocarboxylic acid made ester, and the ester made again amides. The functional group. A functional group is a reactive portion of a molecule. The carbonation of functional group with hydrocarbon produce a vast number of compounds. Particularly types of reaction are associated with the functional group with different structural attachment, giving rise to name associated with some compounds. Normally, these things